Hello and welcome. We're going to go over the problem valid parentheses today. And so we're going to use the umpire process to go over this problem. So let's start. So the problem description is given a string as containing just the characters, the open parentheses and close parentheses, open uh, braces and close braces and open brackets and close brackets. Determine if the input string is valid. An input string is valid if the open brackets must be closed by the same type of brackets. Open brackets must be closed in the correct order, and every closed bracket has a corresponding open bracket of the same type. Okay, so let's go about understanding this problem. So our input is a string containing only brackets, braces, and parentheses. And then we have an output, which is true if valid braces, valid string, false. And we have the conditions here, open brackets must be closed by the same type of brackets, open brackets must be closed in correct order, and every closed bracket has corresponding open bracket of the same type. So I'm not going to type that out. I'm just going to go over some examples so we have an understanding of what we're looking at. So if the string is uh, an open parentheses and a closed parentheses, then it's going to be a uh, valid string, so it's going to be true. And then if we have a sequence of open, closed parentheses and brackets and braces, we also have a valid string, so that's true. And if we have a case where we have one open brace and one open bracket and one closed bracket, then that case is going to turn out to be false. So just a basic understanding of what's going on. Let's move on to the match phase of this problem. So matching this phase, it's similar to problems uh, using a stack. So we're going to implement a stack. So that's pretty much it. And it's a string manipulation problem. So let's go about and plan this thing out. So we're going to implement. So we're just going to write that we're going to implement a stack to solve this problem. And basically, what we're going to do is we're going to create a stack, and we're going to determine, or we're going to put in all the left braces or brackets or parentheses, and we're going to see if they're closed by some kind of right brace or bracket or parentheses. So basically, if we look at example 2, we're going to take in the first left brace or left parentheses and put that into the stack, and then we're going to look at the second element, and that element is a closed brace. So we're going to see if that closes the left brace, and if it does, then we're going to pop off the the left brace from the stack. So we would have 0 elements in the stack. And then the next step would be to go to the next element and see if that's a left or right brace. If it's a left brace, then we're going to stick that into the stack. And then we go to the next element and see if that's a left or right brace. If it's a right brace, then we see if it closes the left brace, and it does. So that's going to be popped off the stack. So we have an empty stack. And then the next step is we're going to the next element. The next element is the left brace. So it pops in, or we put that into stack, and then the last element is a right brace, so we're a right brace, so we're going to check to see if that closes the left brace. And it does, so it's popped off the stack. And so if the stack is empty, then we have a valid string. If it's not empty, then it's going to be not a valid string. Okay, so another example is like we have something like this, which is a series of nested braces or something like that. So we're going to just pop each one of these left braces into the stack. Then once we hit the right brace, we're going to check to see if it closes the left brace, and then it does. So it's going to be popped up. The left brace is going to be popped out the stack, and then we're going to increment one less to the left, to the next left brace, and increment one more to the next element of the string, and then we're going to compare those two and see if they close the brace, and they do. So we're going to pop the left element off the stack, and then we're going to continue doing that until we pop every element off the stack and we have an empty stack. So that's just an example of a corresponding implementation of this problem, or implementation of the stack. And then if, for example, we have um, one left brace, one brace left over or something like that, then we can say that that it didn't get popped off the stack. So it's going to be remaining there, and it's not empty, so it's going to be an invalid input. Okay, so let's go about implementing this process. So we're going to create a stack, and then we want a dictionary of the elements here. So each left brace is closed, or is corresponding to its right brace. Okay, and then we want to initialize a count for the stack, and we want to initialize a count for going through the elements of the string. And then we want to append the first elements to the stack. And then we want to check if S0 and dict values, this is just a corner case, then return false. So that's just if we begin with one of these right braces, then then we can never close a left brace. So it's going to be false, invalid string. So while I is less than length S, we're going to check if the stack is empty or the stack is in the keys. And if so, if Si, the next element, is in the keys, then we want to add that to the stack and increment the count by 1 and the I by 1. Else, if the stack is empty, and SI is in big values. And then check this corner case dimension, return false. And then if SI doesn't equal big stack, and return false, else we're going to pop the element off the stack, and we're going to decrement the count by 1 and increment the count of I by 1. And then we will so we want to include if stack is not empty and stack count is not in the keys, then the stack equals empty and SI and dic values and return false. And their stack counts doesn't equal to dic stack count minus 1. And return false. Else we want to pop off the stack and decrement the count by 1. Yeah. We want to exit the while loop, and if stack equals the empty set, true, false. Accepted. Okay, this is a valid submission. So let's go over and look at Python tutor and review this process. So we're just going to step through this problem with this example, this valid string. And so we just created the stack with the dictionary, and we set the count and I equal to 1, or count equals 0 and I equal to 1, and then we pinned the first element of the stack and the 0, checked the 0 value, and we skip that, and so we go into the while loop and increment, or we're going to add SI into the stack for the first 3 elements. And then we're going to check if the stack is valid, or the next element is valid, and it is valid. So we're going to pop the second element off the stack, and then the next element in the string is going to be a close brace as well. So we're going to check to see if it's valid. I mean, it's valid with the first element in the stack, and it is, so we're going to pop that off the stack. And then the last element in the string that's a closed brace is going to be popping the last element of the stack off, popping the last element stack off. And then we're going to increment and go into the list and see that we add the open parentheses to the list, and then we're going to check to see if the next element is going to closes it, and it does. So it's popped off the stack, and then we return, and we return it's true. So that's the view of the problem. Now let's go over the evaluation of this problem. So we have an open time complexity solution, and that's just because we go through while the entire length of the string, and we just increment the entire string, or increment through the entire string at once. And it's O(n) space complexity as well, because we use the stack, and the stack is going to store all the values, or at least all the values inside. So that's going to use up space. So and it's I guess it's storing at least half the values in the space. So it's O(n) space complexity. So that finishes this analysis of this problem. So thanks for listening.